Am I audible now? You're not audible. Hello? 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 Am I audible now? Hello? Uh, இப்ப கேக்குதா நான் பேசுறது?
Sir.
Am I audible?
Yes.
Am I audible now?
Hello. Are you audible?
Yes, I'm able to hear you. But are you able to hear me now? Hello.
Sir, your voice is audible.
Uh, start. Can I start presenting now? Okay, thank you. So I'll share my slides. So are you able to see the slides on the screen? Are you able to see the slides? Okay, fine. So first of all, I would like to thank the organizers, especially Savitha Madam and John, for uh, giving this opportunity. And I am so glad to give this presentation because last year I was there. Unfortunately, this year I have some other issues, so I could not come there personally. But I hope you will like this presentation. So the title of my talk is Weak Relation Assisted CH Functionalization Using Cobalt Catalyst, a Sustainable Approach. Um, so I'll just since most of the students here are undergraduate students, I want to go a bit slow. So first I would like to give a brief introduction about what is CH bond activation. We have in organic chemistry, most of the time we see that most of the reactions involve cleavage of a bond and formation of a new bond. So we cleave an old bond and form a new bond. Generally, if you notice, most of these reactions involve cleavage of a carbon heteroatom bond. If we have to cleave a carbon hydrogen bond, it is very difficult. So lately there are new techniques that have been developed to cleave a carbon hydrogen bond and do some functionalization of carbon hydrogen bond. The reason why carbon hydrogen bond is difficult to functionalize because carbon and hydrogen they have same electronegativity, and so they are not polar. So that is why breaking of carbon hydrogen bond is considered very difficult. So this is the general schematic diagram of the CH bond activation process. This is a very recent development in organic synthesis. Here you can see there are two CH bonds. One CH bond is close to this DG. This DG means directing group. What happens is this directing group coordinates with the metal and then activates the proximal CH bond, the bond that is closer to the DG, and forms a carbon metal bond. This process we call it as CH bond. And you get the functionalization here. So this is the process. You break a CH bond and put a functional group. You particularly break the CH bond that is close to the directing group, not the one that is far away. You see this far away CH bond is staying intact. So this is the whole concept which we are working on. It is called popularly known as CH bond activation process. This is of current interest. Many researchers across the world are working in this concept, and we are one of them. So in the last slide, I showed something called DG. DG means directing group. In the next slide, I want to differentiate what all there are different directing groups available. There are strongly coordinating directing groups available, and there are weakly coordinating directing groups available. We can use either one of them. But in the next couple of slides, I will tell you why a weakly coordinating directing group is better than the strongly coordinating directing group. So, strongly coordinating directing groups are groups such as pyridine, quinoline, picolinamide, and pyrimidine. These are large groups, and they need to be installed on the substrate. Here you can see here, pyridine is attached to this benzene ring. We have to attach this pyridine ring to the benzene ring. That adds one step. And then the metal comes in coordinates with the directing group and then activates the CH bond. You form a carbon-metal bond. That is then functionalized. The problem with the use of this strongly coordinating group is that even though you are able to directly functionalize the CH bond to carbon carbon with a functional group, directing group stays intact after the functionalization. If we have to remove this, we have to use very harsh conditions, and often it is very difficult to remove. So this is a serious limitation of CH activation using strongly coordinating directing group. Now I'll talk about CH activation by using weakly coordinating directing groups. What are weakly coordinating directing groups? Weakly coordinating directing groups are aldehyde, ketone, ester, and acids. These are small groups which are present in many commercially available substrates. So we can directly buy them and use it. We don't have to go for additional steps to introduce it because it's so commonly available in many organic molecules. So directly we take the substrate and do a CH activation, and we get the functionalized product. And in addition to this functionalization, we can use these functional groups, weakly coordinating functional groups, as a handle for doing further functionalization. So the point that I wanted to mention here is that CH activation by using weakly coordinating directing groups such as aldehyde, ester, ketone is better than strongly coordinating directing groups. So this is the one point that I wanted to make strongly here. These are very costly metals. They are heavy metals. You can see these metals are coming in the periodic table in the fourth and fifth row. These are heavy metals, and heavy metals are proven to be toxic. It has been proved that these metals are toxic. So if we can replace this metal with phosphor transition metals, that are 3D transition metals, they are not only less expensive. You can see here cobalt, which is a phosphor transition metal, is actually much cheaper than the heavy metals. So we could use these metals. It will be less toxic. One second, there is some problem. So it is less toxic, and also it is less expensive. So use of phosphor transition metals such as cobalt for CH activation is better than using these heavy metals. So far, I have told you two important points. One is we could use weak coordinating directing group, that is better, and we could use 3D transition metals such as cobalt, which is also a good better option. So now, depending on the directing group that is used and the type of metal that is being used in CH activation, we can classify CH activation into four categories. The least sustainable category is use heavy metals along with the strongly coordinating directing groups such as pyridine. And the next better approach would be use weakly coordinating directing group, but still using these heavy metals such as 4D and 5D metals. slightly better would be to use a first role transition metal, along with the strong coordinating directing group such as pyridine. The best approach of CH activation is use a weakly coordinating directing group such as ketones and a first row transition metal, 3D transition metal such as cobalt. So our group has been working in this concept, using first row transition metal and weakly coordinating directing group for a number of years. This is a recent review that we have written in ChemCom. This is one of the highly cited review in this topic. With this background, now I will start my work, discussing about my work. Indole is a very common heterocycle present in many natural products and drug molecules. Many of the drugs that we take for different diseases, they have indole in them. So these are some of the natural products containing indole scaffold. And since these are indole containing molecules are having medicinal properties, functionalizing indole CH bonds is of very much important. C2 and C3 position of indole has been extensively functionalized, whereas C4, C6, C7, and C5 positions of indole has not been very much explored. So we decided to do this functionalization, for example, C4 functionalization. Um, so in 2019, we developed a method for C4 functionalization of indole using acrylate using CP star cobalt catalyst. As a extension of this work, we decided to use acetylene, diphenyl acetylene instead of acrylate, and get this olefinated product. But surprisingly, instead of getting olefinated product, we got this acyloin product. Since acyloin product is also an important intermediate in organic synthesis, we thought we will optimize this product and try to get a good yield, because initially we got less yield. So we went ahead and optimized for the sake of time. I'm not going to go into the details of the optimization process. Here I'm just going to show you the results. We have done a lot of optimization and found this condition and that gives good yield for a variety of different substrates. Generally, when we discover something new, we have to test that on different derivatives of the molecule. For example, this is simple indole, and here you instead of methyl we have ethyl here. Instead of CH we have fluorine here. Chlorine here, bromine here, methyl here. So we derivatize the indole and see whether it works or not. And in fact, to our delight, it is working well with most of the derivatives, and it's giving good yield also. So now this is a very well established methodology. Instead of using diaryl alkyne, you have aryl here, aryl here. Instead of diaryl alkyne, we thought we will replace one of the ring with alkyl group and see what happens. So when we did that, we put ethyl group here and vinyl group here, and then we did this reaction. When we did this reaction with this coupling partner, we found that the hydroxy group is getting eliminated, and we are getting this enone kind of system. So that's what happens when you do some small changes. The reaction course completely changes. So here we just observe elimination of a water molecule. So after establishing this methodology with two different coupling partners, we went ahead for discovering the mechanism of this reaction. Generally, what happens is that after you establish methodology, we have to study the mechanism. Then only the journals will accept the paper. So we started the mechanistic study. One of the things that we do in mechanistic study is that we isolate all the byproducts of the reaction, because sometimes we get idea from the byproducts on how this reaction is proceeding. In this case, this is the TLC of this reaction. This is the product, this is the starting material, and this spot is the coupling partner. There is one additional spot here. We isolated that, and we found that this is a monoketone. Okay. So monoketones are if you look at this monoketone, it is clear that this is derived from this diphenyl acetylene. If we add one molecule of water, it will form enol, and enol can automerize to give this ketone. So that
So
tells
that
that there
tells
must
that
be
there
some
must be
water
some
in this
water in this
reaction mixture.
reaction mixture.
So,
So,
in order
in
to
order to
understand that
understand that
there is
water,
water, or whether the
or whether the
water is
water is
responsible for
responsible
giving
for
this
giving this
product,
product,
we
we
deliberately
deliberately
added
added
water in the
water in
reaction
the
mixture.
reaction mixture.
You can see
You
here
can
we
see here
added
we added
O18 labeled
O18 labeled
water,
water,
isotopic
isotopic
labeled water.
labeled water.
So when we
So when we
added this
added this
isotopic
isotopic
labeled
labeled
water,
water,
5
5
equivalents,
equivalents,
we found
we
that this
found that
water
this
is
water
going
is
to the
going to the
product.
product.
Oxygen is going
Oxygen
to
is
the
going to
product
the
in this
product in
product
this
as well
product
as in
as
this
well as in
product.
this product.
So this is a
So this
clear
is a clear
proof,
proof,
and this is
and this is
confirmed by high
confirmed by high
resolution mass
resolution mass
spectrometer.
spectrometer.
There is a
There
4
is a
unit
4
jump
unit jump
in the mass
in the
peak.
mass peak.
This clearly
This clearly
establishes that
establishes that
the
the
water
water
is
is
actually
actually
reacting
reacting
with
with
the
the
alkyne.
alkyne.
So having
So having
proved
proved
the source
the
of water,
source of water,
having
having
proved
proved
the
the
formation of this
formation of this
product,
product,
our
our
next task
next
is to
task is to
find where is
find
this
where is
water
this
coming
water
from.
coming from.
Because if you look
Because if
at
you look at
this is the
this is the
standard reaction
standard reaction
condition.
condition.
I'm sorry, there
I'm
is a
sorry, there
mistake.
is a mistake.
This
This
must
must
be
be
10 more
10 more
percentage.
percentage.
If you look at
If
this
you look at this
condition,
condition,
you see
you
that
see that
there
there
is
is no
no
water
anywhere in
anywhere
this
in this
condition.
condition.
But still,
But still,
we find
we
that
find that
the water
the
reacting
water
with this
reacting with
alkyne.
this alkyne.
So this
So this
indirectly
indirectly
tells that
tells that
water must be
must
there
be
in the
there in the
solvent.
solvent.
Okay, in the
Okay, in
solvent.
the
So
solvent.
what we
So
did
what we
was that
did was
we
that
dried
we
this
dried
solvent
this
several
solvent
times.
several times.
TFA is
TFA is
trifluoroethanol.
trifluoroethanol.
Even after
Even
several
after several
trials,
trials, we
found that
found that
this reaction
this
is
reaction is
consistently giving
consistently
this
giving
yield,
this yield,
which means
which means
that
that
the
the
TFE is
TFE
actually
is
dry,
actually dry,
and it's
and
not
it's not
moist.
moist.
That means
That means
water is
water is
probably
probably
generating from
generating from
TFE. So
TFE.
this was
This
the
was
thought
the
process
thought
that we
process
had.
that
So
we
we
had. So
took
we took
trifluoroethanol and
trifluoroethanol
added
and
different
added different
salts
salts
to see whether
to
we are
see whether
getting
we are
any
getting any
byproduct. So one
byproduct.
of the
So
things
one of
that
the
we
things that
observed
we
was
observed
with
was with
trifluoroethanol in
trifluoroethanol
the
in the
presence of
presence of
AgBF4,
AgBF4,
we were able
we
to
were able
detect
to
this
detect this
ether,
ether,
which
which
indirectly proves
indirectly
that
proves
water
that
is
water
forming
is
in the
forming in
reaction
the
mixture.
reaction mixture.
But this is
But
not
this
a
is
good
not a
enough
good
proof
enough
because we
proof
have to
because we have to
quantitatively prove
quantitatively prove
the
the
formation of
formation
water.
of water.
So we
So we
decided to do
decided
the
to do the
F19 NMR
F19
study.
NMR study.
We took
We
the
took
fluorine
the
tagged
fluorine tagged
substrate,
substrate
with a
substrate with
fluorine,
a fluorine,
and then
and
we
then
run this
we run this
reaction,
reaction,
and we
and we
detected the fluorine
detected the
signal
fluorine
for the
signal for the
product as
product
well as
as
this
well as this
ether.
ether.
Okay, now in the
Now
next
in the
slide
next
I will
slide
show
I will
you
show
how
you
we
how we
detected it.
detected it.
So this is
So
the
this is
NMR
the NMR
spectrum
spectrum
of
of
this
this
ether.
ether.
So this is
So this is
the
the
fluorine
fluorine
signal for the
signal for
pure
the
ether,
pure ether,
and this is
and this
the
is
fluorine
the
signal
fluorine
for the
signal for
pure
the pure
trifluoroethanol.
trifluoroethanol.
So
So
this is the
this is
ethanol
the
that we
ethanol that
used
we
just
used
before the
just before the
reaction. So you can
reaction.
see
So you
this
can see
baseline
this
is
baseline
clear.
is clear.
There's no
There's
nothing else is
nothing else
present.
is
No
present.
ether is
No
present
ether
in
is
the
present
solvent.
in the solvent.
So then
So then
when we took
the
the F19
F19
of
NMR
the
of the
reaction
reaction
mixture,
mixture,
we found
we found
trifluoroethanol, and then
trifluoroethanol,
we
and then
found
we
this
found
ether
this
peak
ether
coming
peak
up.
coming up.
What it
What
tells
it
us is
tells
that
us is that
within the
within the
reaction
reaction
mixture,
mixture,
after some
after
time,
some
this
time, this
trifluoroethanol is getting
trifluoroethanol is getting
converted to
converted to
this ether,
this ether,
which
which
indirectly
indirectly
proves that a
proves that a
molecule is being
molecule of water is
generated.
being
And in
generated.
fact, we
And in
have
fact, we
taken
have
the
taken the
integration of this
integration of
peak
this peak and this peak,
and the
and
ratio is
the
about
ratio
1
is
is to
about 1
6.
is to
6.
6.
I mean, this is
I mean,
1
this
and
is
that is
1 and
6.
that is
So which
6. So
means
which
there's
means
6
there's
equivalents
6
of water
equivalents of
is being
water is being
generated in the
generated in the
reaction
reaction
medium, which is
medium, which
sufficient
is
enough
sufficient
to
enough to
get
get
oxygen at these
oxygen at these
places.
places.
After having
After having
successfully
successfully
established the
established
source
the
of
source
water,
of water,
our next
our next
attention turned
attention turned
towards
towards
discovering what is the
what is
actual
the
coupling
actual
partner
coupling
in this
partner in this
reaction.
reaction.
If
If
diphenylacetylene had been
diphenylacetylene
the
had been
coupling
the
partner,
coupling
we should
partner,
have
we
got the
should have got
olefin
the
product.
olefin product.
So we
So
thought
we
maybe
thought
something
maybe
is
something
happening
is
to
happening to
diphenylacetylene to other products. Of course, we isolated this monoketone.
monoketone.
So we
So we
decided to check
decided to
whether
check
these are
whether
the
these
actual
are the
coupling
actual
partners.
coupling
So we
partners. So
thought
we thought
that maybe this
that maybe this
diketone could be
diketone could be
the
the
coupling partner.
coupling
So
partner.
we
So we
took the
took the
commercial
commercial
available
available
diketone
diketone
and did this
and did this
reaction,
reaction,
and we
and
found
we
that
found that
surprisingly we
surprisingly
couldn't
we
get
couldn't get
this
this
product.
product.
What it
What it
tells is
tells
that
is
this is not the actual coupling partner. Then we
Then we
decided to use
decided to
this
use this
monoketone
monoketone
instead of
instead of
diketone
diketone
in this
in
place.
this place.
Again, we did not
Again, we
get the
did not
product.
get the
So
product.
what it
So
tells
what
is
it
that
tells is that
only
only
diphenylacetylene is
diphenylacetylene is
reacting and it is
reacting and it
something
is
else is
something else
happening
is
in the
happening in the
reaction medium.
reaction medium.
We were not
We were not
knowing what is
knowing what is
happening
happening
at that
particular
particular point
point
of
of
time.
time.
So then we
So then we
decided to
decided
do
to
other
do other
studies
studies such as
derivatization
derivatization
studies.
studies.
One of the things
One of
that
the
we
things
have
that
to
we have
do
to do
nowadays
nowadays
is that
is that
we have to
we have to
show some
show some
applications of the
applications of the
product.
product.
So we were
So we
trying
were
to do the
trying to do the
derivatization of this.
derivatization
This is
of
the
this. This is
product
the
of our
product of our
reaction.
reaction.
We were trying
We
to
were
do
trying to do
derivatization of this
derivatization
with
of this
different
with
different
different
conditions.
conditions.
So when we
So when we
subjected
subjected
this
this
molecule to this
molecule to this
condition, we were
condition, we were
getting
getting
deoxygenated product. You
deoxygenated
can
product.
see
You
here
can see here
hydroxy is
hydroxy is
removed. In that
removed. In
place, we
that
have
place,
this
we have this
hydrogen.
hydrogen.
So we
So
observe the
we
same
observe the
thing
same
even
thing
in a
even in a
different
different
condition. So we
condition.
were
So
trying
we
to
were
protect
trying to
this
protect this
ketone
ketone
using this protection
even
condition.
in this
Even in
case
this
also
case also, we were
getting
getting this
this
deoxygenated product. This
deoxygenated product. This
hydroxy is
hydroxy
removed,
is
and in
removed,
that
and in
place you
that
are
place
having
you are having
hydrogen.
hydrogen.
So
So
this
this
struck us,
struck us,
maybe
maybe
this
this
product might
product
be the
might be the
intermediate in the
intermediate in the
reaction mixture.
reaction mixture.
So what we
So
did,
what we
we
did, we
isolated this
isolated this
products,
products,
and then
and
this is
then
the
this is the
hydrogen
hydrogen
containing product,
containing product,
and then
and then
subjected this
subjected this
product
product
to the
to the
standard
standard
condition. This is the
condition. This is
standard
the standard
condition which we
condition which we
discovered
discovered
initially.
initially.
And
And
surprisingly, this
surprisingly, this
hydrogen is getting
hydrogen is getting
oxygenated.
oxygenated.
So what it
So what it
tells is
tells
that
is that
this is an
this is an
intermediate
intermediate
product in the
product in the
reaction medium.
reaction medium.
So
So
with this
with this
discovery,
discovery,
we
we
again
again
wanted to see
wanted to
whether there
see
is
whether
any
there is
effect
any
of the
effect of
catalyst.
the
So we remove
catalyst.
the
So we remove the
catalyst and
catalyst and we
retain only the
retain only the
oxidants.
oxidants.
And
And
even
even
without the
without the
presence of
presence of
this
this
catalyst,
catalyst,
this
oxygenation
is taking
is
place,
taking
which
place,
means
which means
this
simply
is simply an
oxidation
oxidation
reaction.
reaction. And then we
And then we
also wanted
also
to
wanted
test
to
whether this
test whether this
reaction is
reaction
going
is
by
going by
radical
radical
mechanism or
mechanism
ionic
or ionic
mechanism. So
mechanism. So
generally, what we
generally,
do
what
is
we
that
do is that
we add
we
some
add
radical
some radical
scavengers.
scavengers.
So if
So
this
if this
mechanism is
mechanism
through
is through
radical
radical
process,
process,
then the
then the
radical
radical
scavengers will
scavengers
stop
will
this
stop this
reaction.
reaction.
So
So
tempo and
tempo and
VSV
VSV
are very
are
well
very
known
well
radical
known radical
scavengers.
scavengers.
When we
When
added
we
these
added
radical
these radical
scavengers,
scavengers,
this reaction
this
did not
reaction did
stop.
not
We
stop.
got
We got
a good
a good
reasonable
reasonable
yield of the
yield of the
product. What
product.
it tells
What
is
it
that
tells
this
is that
reaction
this
is not
reaction is
going
not
by
going by
radical
radical
mechanism.
mechanism.
Um,
Um,
we
we
also
also
wanted to
wanted to
detect what is
detect
the
what is
actual
the actual
intermediate
intermediate
forming
forming in this
reaction.
reaction.
So
So
we did
we
this
did this
study.
study.
We
We
subjected this
compound
compound
with
with
one
one
equivalent
equivalent
of
of catalyst,
catalyst,
and it is
nicely
nicely forming this
cobalta
cobalta
cycle
cycle
intermediate.
intermediate. You can see
You
here
can see
cobalt
here
is sitting
cobalt is
here,
sitting here,
and that's
and
proven
that's
by this
proven by
high
this high
resolution mass
resolution
spec.
mass spec.
So it
So
proves
it
that
proves that
cobalt is
cobalt is
indeed
indeed
coordinating with this
coordinating with this
directing group
directing group
and
and
activating the
activating the
CH bond
CH
here,
bond here,
and then
and
forming
then
a weak
forming a weak
cobalt carbon metal
carbon
bond,
metal bond,
cobalt bond.
cobalt bond.
And then
And then
reviewers asked
reviewers
us,
asked us,
why is
why
this
is this
forming the
forming the
six-member
six-member
metalla cycle?
metalla cycle?
Why
Yeah.
is it
Why
not
is it
forming
not
the
forming
five-member
the
metalla
five-member
cycle
metalla
and
cycle
giving
and
the
giving the
C2
C2
functionalization? So then
functionalization?
we
So
did the
then we did the
calculation,
calculation,
computation,
computation,
calculation.
calculation.
Metalla cycle. With this
With this
information,
information, I would like to
explain the
explain the
mechanism of this
mechanism of this
reaction.
reaction.
At first,
At first, cobalt
forms an
forms
active
an
cobalt
active cobalt
catalyst.
catalyst.
This then
This then
coordinates with this
coordinates with this
oxygen and then
oxygen and
forms a
then forms a
cobalta
cobalta
cycle.
cycle.
This we have
This we
proved by
have
high
proved by high
resolution mass
resolution
spec.
mass
A
spec.
few
A
slides
few
ago, I
slides
have
ago,
shown
I have
this one.
shown this one.
And then
And
the
then the
alkyne
alkyne
coordinates with the
coordinates with the
cobalt,
cobalt,
and it
and it
inserts.
inserts.
This is the
This
key
is the
step
key
where
step
the
where the
oxygenation take
oxygenation
place.
take place.
The water
The
that is
water that
generated
is
from
generated from
TFE
TFE
ligates with the
ligates with the
cobalt and
cobalt and
undergoes
keep
reductive
reductive
elimination to
elimination
give this
to give this
enol.
enol.
The enol
The
then
enol then
tautomerizes
tautomerizes to this
ketone.
ketone.
This is the
This is the
ketone that
ketone that
we were
we were
obtaining as a
obtaining
side
as a
product
side
in
product
our
in our
other
other
application
application
studies.
studies.
So we have
So we
already
have already
proved
proved
that this
this
deoxygenated product
deoxygenated product undergoes
oxidation in the
oxidation
presence
in
of
the presence
silver
of
and copper
silver and copper
salts.
salts.
So
So
we
we
propose that
propose
this is
that this is
formed, and
formed
this
and this
undergoes
undergoes
oxidation to get
oxidation
this
to get this
hydroxy group.
hydroxy group.
And if
And if
R1
R1
is
is
an
an
alkyl group,
alkyl group,
this
this
hydroxy undergoes
hydroxy undergoes
elimination to get
elimination
this
to get this
enol product.
enol product.
So now I
So
have
now I have
explained
explained
one
one
work that
work
we have
that we
done
have done
with cobalt
with cobalt
catalyst
catalyst
using
using
weak chelation.
weak chelation.
Now I'll
Now
talk
I'll
about
talk
another
about
work
another
that we
work
have
that we
done
have done
using cobalt
using cobalt
catalyst.
catalyst.
Catalani reaction
Catalani
is a very
reaction is a
famous
very famous
reaction.
reaction.
It
It
involves
involves
1,2-difunctionalization of a
1,2-difunctionalization of a
haloarine.
haloarine.
It was
It was
discovered in
discovered in
1997 by
1997
Marta
by Marta
Catalani and
Catalani
later on it was developed by a Canadian scientist. So I will now quickly discuss about the mechanism of this reaction. It's a very interesting mechanism. The first step is palladium inserts between this carbon halogen bond and then adds to this double bond and forms this intermediate
This
intermediate
then
then
activates the
activates the
CH bond
CH bond
to give
this
this
metalla
metalla
cycle.
cycle. Now this
Now
metalla
this
cycle
metalla
have
cycle
two
have
beta
two beta
hydrogens.
hydrogens.
If this
If
beta
this beta
hydrogen
hydrogen
eliminates,
eliminates,
you
you
should
should
get
get
this
this
product.
product.
But this
But
doesn't
this doesn't
happen
happen because
this
this
hydrogen
hydrogen is
is
anti to
anti
this
to this
carbon
carbon
palladium
palladium
bond.
bond. Generally, beta
Generally,
hydrogen
beta hydrogen
eliminations are thin
eliminations are thin
eliminations.
eliminations.
Here the
Here the
geometry is
geometry is
anti.
anti,
Therefore, this
therefore this
elimination doesn't
elimination
take
doesn't
place.
take place.
Now
Now
this
this
hydrogen also
hydrogen
doesn't
also
undergo
doesn't undergo
elimination
elimination
because
because
if
if
this
this
undergoes
undergoes
elimination, it will
elimination, it
give
will
bread
give bread
compound,
compound,
and
and
anti-bread
anti-bread
compounds are
compounds are
unstable.
unstable.
So
So
the
the
this
this
intermediate has no
intermediate has
other
no other
option
option
other than
other
just
than just
reacting with the
reacting with the
electrophile and
electrophile
get the
and get the
functionalization here.
functionalization here.
With this
With
and
this
then
and then
undergoes
undergoes
extrusion of
extrusion of
norbornene
norbornene
to give this
to
one
give
to
this
difunctionalized product.
difunctionalized
This is a
product.
very
This is a
famous
very
reaction.
famous reaction.
The beauty of
The
this
beauty of this
reaction is that
reaction is that
palladium and
palladium and
norbornene strike
norbornene
a
strike a
perfect
perfect
balance of
balance of
cooperative
cooperative
reactivity
reactivity
in this
in this
reaction.
reaction.
If you
If
replace
you replace
palladium
palladium
with any
with
other
any
metal,
other metal, this reaction doesn't work.
if you
If
replace
you replace
norbornene with
norbornene with any
metal,
other metal,
olefin,
olefin,
again this
again
reaction
this
doesn't work.
reaction doesn't
They
work. They
form a
form
perfect
a
pair
perfect pair
for this
for this
particular
particular
transformation.
transformation.
I'll now
I'll now
quickly
quickly
give you
give you
the
the
statistics
statistics
of Catalani
of
reaction
Catalani
for
reaction
different
for
metals.
different
You
metals.
can
You
see
can see
all the
all the
Catalani reactions
Catalani
that have
reactions
been
that have been
reported so
reported
far
so
have
far
used
have
only
used only
palladium mostly,
palladium
and
mostly,
very
and
very
very
few
very
reports
few
with
reports
rhodium.
with rhodium.
And
And with these
these both
both
are
are
heavy
heavy
metals.
metals.
With
With
cobalt, there is no
cobalt, there is no
report.
report.
So we
So
thought
we
if
thought
we
if
can
we
do
can
this
do this
transformation with
transformation with
cobalt,
cobalt,
it
it
will
will
not
not
only
only
reduce the
reduce the
cost, but
cost,
it is
but
also
it is
less
also less
toxic
toxic
and it is
and it
easily
is easily
available.
available.
So that was
So
one
that
of
was
our
one of
idea
our
that to
idea that to
replace.
replace.
Once again,
Once
I
again,
think I'm
I
not
think I'm not
audible.
audible.
Getting a call.
Getting a call.
Am I
Am
audible?
I audible?
Can I go
Can
ahead?
I go ahead?
Just show me
Just show
in
me
sign
in
like this.
sign like this.
Then it's fine.
Then it's fine.
I'm not able to
I'm not
hear
able to
anything.
hear anything.
Yes. Okay.
Yes. Okay.
So
Yeah.
yeah.
One second.
Sorry for the interruption. Is my slides visible? Okay. All right. So we thought we will do this reaction with cobalt. If we do it with cobalt, and it will be a step ahead towards greener and sustainable catalysis. Um, I, I,
I, I,
I'll finish
I'll finish
quickly.
quickly.
I don't take
I
much
won't take
time.
much time.
Um,
Um,
so
this is the
this is the
olefin that has
olefin
been
that has been
used in
used
Catalani
in
reaction.
Catalani
You can
reaction.
see
You
so
can
many
see so
different
many different
olefins that has
olefins
been
that has
used,
been used,
narbolines,
narbolines,
and
and these are all of them
retain the
retain
same
the same
bicyclic
bicyclic
scaffold,
scaffold,
and these are
and these are
difficult to
difficult to
synthesize.
synthesize.
So we thought
So
we
we
could
thought we
just
could just
replace this.
replace this. If we can replace this olefins with simple olefins
olefins
such as
malimite,
malimite,
it is
cost
cost
effective and
effective and
synthetically
synthetically
easily
easily
accessible.
accessible.
With this idea
With
in
this
mind,
idea
we
in
want to
mind, we
test
want to
this
test this
new
new
hypothesis on
hypothesis
known
on known
reaction. This is a
reaction.
known
This is a
reaction
known
reported
reaction
by
reported by
Glorious,
Glorious,
wherein
wherein
he
he
has
has
used
used
this
this fancy
norbornene and
norborneen and
CP star
CP
rhodium
star rhodium
catalyst.
catalyst.
We thought
We thought we
will
will
replace
replace
this
this
CP star
CP star
rhodium
rhodium with
first row
first
transition
row
metal
transition metal
cobalt,
cobalt,
and also
and
this
also this
olefin with the
olefin with the
malimite. So this
malimite.
is
So
our
this is
idea,
our idea,
and we want to
and we
test
want to
whether this
test whether
works.
this works.
After a lot of
After a lot of
trials,
trials, indeed it worked,
and this is
and this is
the
the
various
various
substrate
substrate
scopes.
scopes.
You can see
You
a
can
lot
see
of
a lot of
substrates are
substrates are
working well
working
in
well
this
in this
condition,
condition,
and we
and we
also
also
did
did
mechanistic study.
mechanistic study.
So we did a
So we did a
crossover
crossover
experiment to
experiment
see
to
whether
see
this
whether this
reaction is
reaction is
intramolecular or
intramolecular or
intermolecular.
intermolecular.
So here
So
we took
here we took
different
different
substituents on the
substituents on the
substrate and
substrate and
different
different
acyl groups,
acyl groups,
amide groups
on
on
these
these
two.
two. So if this is
So if this is
intramolecular, for
intramolecular,
methyl
for
substrate,
methyl
only
substrate,
this
only this
ethyl
ethyl
propionamide
propionamide
will get
will get
transferred. So
transferred.
you can
So
see
you
for
can see for
methyl,
methyl,
propionamide got
propionamide
transferred.
got transferred.
For
For
fluorosubstituent,
fluorosubstituent, the
acetamide
acetamide
substituent
substituent
will get
will
transferred.
get transferred.
So that's what
So that's what
happened. And
happened.
so what
And
it
so
tells
what it
is that
tells is that
it's an
it's an
intramolecular
intramolecular
process.
process.
We've also
We've also
detected the
detected the
intermediate.
intermediate.
This is the
This is the
catalytic cycle.
catalytic cycle.
First,
First,
the metal
the metal
coordinates with the
coordinates with the
directing group and
directing group and
activates the CH
activates the
bond and
CH bond and forms a
metal bond.
metal bond.
And then
And
olefin
then olefin
inserts.
inserts.
Then
Then
the cobalt inserts
cobalt
between the
inserts between
oxygen
the oxygen
nitrogen and
nitrogen and
forms
forms
this
this
intermediate.
intermediate.
This then
This then
forms this
forms this
bicyclic
bicyclic
intermediate.
intermediate. This undergoes elimination
To give
to
this
give this
methyl cycle,
methyl cycle,
and that
and that
undergoes
undergoes
protodemethylation to give
protodemethylation to
this
give this
final product.
final product.
So
So
we in
we
this
in
project
this
we
project
not
we
only
not
want to
only want to
demonstrate the
demonstrate the
application of
application of
cobalt
cobalt
catalyst, but we
catalyst,
also
but we
wanted
also
to
wanted to
try to
try to
show some
show some
application.
application.
So you can
So
see
you
that
can
this
see that this
reaction
reaction
works
works
even with
even with
even with
even with
complex
complex
molecules such as
molecules such
this.
as this.
And it
And
also
it
works.
also works.
It can be
It can be
used.
used.
This product can be
Product
used
can be
with
used with
other
other
coupling partners
coupling
to give
partners to
some
give some
indolo
indolo
fused
fused
heterocycles.
heterocycles.
So we
So
wanted to
we wanted to
show whether
show
this
whether this
product can be
product
used
can be
as a
used as
ligand.
a ligand.
Indeed, it
Indeed,
works
it
as a
works as a
ligand.
ligand. These are
Different
different
products
products
that we
that we
obtain.
obtain.
We
We
tested these
tested these
products as a
products as a
ligand in
ligand
this
in this
particular
particular
reaction. All of
reaction.
them
All of
works,
them works,
and you see
and you
without
see
ligand
without
the yield
ligand
is
the yield
less.
is
So that
less. So
means
that means
these
these
products
products are indeed
acts as a
acts as a
ligand.
ligand. Can be
Considered as a new
considered as a
type of
new type
ligand.
of ligand.
So, and
So,
we
and we
demonstrated with
demonstrated
different
with different
molecules.
molecules.
So just
So
before
just
we
before we
published this
published
work,
this
there
work,
was
there was
another
another
group that
group that
published
published
not same
not
work
same
but
work but
similar
similar
concept.
concept.
So they
So
have
they have
introduced this
introduced this
monocyclic
monocyclic
olefin for
olefin
this
for this
catalanitype
catalanitype
reaction, and they
reaction, and
published
they
in Nature
published in Nature
Synthesis.
Synthesis.
Nonetheless, we were
Nonetheless,
also
we were
happy
also happy because our work
published
got
in
published in
ESS
EFC
catalysis.
catalysis.
So now I'll
So now I'll
quickly
quickly
give you an
give you an
overview
overview
of our
of our
other
other
projects.
projects.
Apart from
Apart
CH
from CH
activation, our
activation,
group is
our
also
group is
working
also
on
working on
CC bond
CC bond
activation.
activation.
So you can
So you
see
can see
strained
strained
molecules can be
molecules can be
functionalized to get
functionalized to get
different
different
heterocyclic
heterocyclic
molecules:
molecules,
melamide,
melamide,
coumarin,
coumarin,
diketones,
diketones,
E9,
E9,
and
and
uh, s-
uh,
um,
s- um,
vinyl
vinyl
cyclobutanol and all.
cyclobutanol and all.
This is a
This
review
is a
that we
review that we
recently wrote
recently
in
wrote
ACS
in ACS
catalysis
catalysis
about
about
CC
CC bond
bond.
activation.
And to
And to
summarize,
summarize,
I have
I
talked
have
about
talked
two
about two
stories. In one
stories.
of the
In one of
story,
the story,
I showed
I
how to
showed
do
how to do
C4
C4
functionalization of
functionalization of
indole
indole
to get this
to get this
acyloin
acyloin
product.
product.
And
And
we have
we have
also
also
shown that
shown
how
that
cobalt
how
catalyst
cobalt
can be
catalyst
used
can be
for
used for
catalani type
Catalani type
reaction.
reaction.
And
And we have not just stopped at this stage. We have taken these products
and
and
demonstrated that it
demonstrated
can be
that it
used
can
as
be
a
used as a
ligand for
ligand
palladium
for palladium
catalyzase
catalyzase
functionalization
functionalization
reaction.
reaction.
So these are
So these
some
are
of our
some of our
other
other
work
work
on CH
on CH
activation.
activation.
We have done
We
a
have done a
number of
number of
heterocyclic
heterocyclic
molecules.
molecules.
We have
We
done
have done
pyridone
pyridone
functionalization. These are
functionalization.
the
These are the
results.
results.
We have also
We have
done a
also
lot
done
of
a lot of
annulation
annulation
reactions. You can
reactions.
see
You can see
many
many
multiple ring
multiple ring
forming
forming
compounds are
compounds
also
are
there.
also there.
So,
So,
and I'm
and I'm
almost
almost
the end
at
of
the
my
end of my
talk.
talk.
Before I
Before I
conclude,
conclude,
I
I
would
would
like
like
to
to also
mention that
mention that
I'm
I'm
also
also
editorial
editorial
advisory
advisory board
member,
member,
and I
and I
was
was
specifically
specifically
told by
told
the
by the
editor
editor
to
to
do
do
some
some
publicity.
publicity.
So
So
here I
here I
am,
am,
and
and
please do
please do
submit your
submit your
articles to
articles to
JOC.
JOC.
And these are the
And these are the
students who
students
worked
who
with me.
worked with
Without
me.
their hard
Without their
work,
hard
these
work,
would not
these
have
would
been
not have been
possible.
possible.
The
The
work that I
work that I
presented
presented
in this
in
talk
this
is
talk
done
is
mainly
done
by
mainly by
Shyam,
Shyam,
Tanmay, and
Tanmay, and
Vedavyas.
Vedavyas.
Shyam is
Shyam
in
is in
Germany.
Germany.
Tanmay is also
Tanmay is
in
also
Germany
in
as a
Germany as
Humboldt
a
fellow.
Humboldt fellow.
Vedavyas is in
Vedavyas is
United
in United
States
States
with Jin
with
Kuan
Jin
Yu.
Kuan
He's
Yu,
also a
who's also
famous
a famous
scientist.
scientist.
So I
So
finally
I
thank
finally
the
thank
funding
the funding
agencies
agencies
for
for
the
the
support.
support.
Without their
Without their
support, it
support,
was
it's
not
not
possible to
possible to
do the
do the
work.
work.
And this is
And
my
this is my
group picture
group
some time
picture some
ago.
time ago.
And
And
finally,
finally,
I
I
thank
thank
you
you
all
all
for
for
your
your
kind
kind
attention.
attention.
I'll be
I'll
happy
be
to take
happy
any
to take any
questions.
questions.
I am not
I
able
am
to
not able to
hear.
hear.
Earlier I was able
Earlier I
to
was
hear,
able
but
to hear,
now
but
I'm not
now
able
I'm
to
not
hear.
able to. Now I'm able.
I am
I
not
am
able
not
to
able to hear
hear
anything.
anything. Sorry about
Sorry
it.
about it.